Okay, let's go on then. Well, just check the streaming again. Yeah, it's okay. Well, before we go to the next slide, except like for the models and objects, like what are two, let's say, most fundamental and essential things we need to have in the scene when rendering? What do we need to take care of and consider when you need to render the scene? What things are important?
Shaders.
No, more conceptual thing, not the way like shader is just like way of implementation, but something that is there in the scene or has to be considered in the scene. Yeah, perspective, yeah, that's one, yeah, exactly. That's very good one. So camera, perspective, to know where you are looking from to the scene, because you can have thing, but its look can differ like from different perspectives. So camera is one thing, and another thing, but just like we need to see anything, what is essential. Light, yeah, that's simple. So this is more generalized tree of hierarchy. We will have a look to more like directed acyclic graphs that is specific like to OpenScene graph, but this is just generalized for all tools. So the idea is that we have one root node, the world, that has like kind of covers everything within the scene. We have light and camera that are essential for the scene, and they don't have children because we just have light and camera. And then we have grouping nodes that are used just to group several instances together. So this group has two children nodes, and each of the groups has like several drawables, so the meshes that are actually visualized, the objects or models or whatever you call it. So where we can define some parameters here, and it's passed down to all the children, or if you define something here, it's passed down to those meshes, and you can define something locally for this mesh as well. And yeah, each branch has its own metrics like rotation, translation, and scaling. So if we have translation metrics for this group, when we translate this group, all those meshes move kind of in a synchronized way. And yeah, we pass from parent metrics to child metrics, and it's a recursive one. We go back again and again. And so like very kind of simple pseudocode-ish example. So for what we do here is like for each child, multiply it by the parent metrics, and then pass down that implementation for all the children. For example, this one is multiplied by like this metrics of this group, and then that multiplication is passed down to those ones, so it penetrates the whole tree. I think it's yeah, combining transformations is that we simply multiply them. So if we get back to here, if we have translation metrics for this one, and then this one moves, so what we get here is the multiplication of translation of this one and this one. And yeah, group nodes, sorry, yeah, group nodes are just like grouping several drawables or other groups, and they can have like as many children as you need, and they move, rotate, scale together, and you can have like same parameters, for example material specification for them also, but it can be also overridden. We will see that soon. And there are like leaf nodes that are end of the structure. The ones that do not have any children are called leaf nodes. For example, geometry, like mesh in this case is a leaf node, light is usually a leaf node, and camera is usually leaf node, and they do not have any children down them. Yeah, what kind of properties can they have? So material color, texture, shaders can be associated to each of the group, or like line thickness, anything like is related with appearance. So we can define that, okay, we have a car body and we have 4 doors of it, and we can define a group car and color black, and the whole car is black. But if you want to have like one of the doors that is red, you can override. So what it does is, actually, if we define black here, everything becomes automatically black, but if you define blue for this mesh, it overrides this black, so this one becomes blue. So you can have that flexibility to, yeah, and those ones just like correspond to OpenGL states. So imagine OpenGL as a state machine. So each of this property or parameter, when it gets value, it sets our OpenGL pipeline to a particular state. And yeah, the same thing that I've already mentioned. Yeah, if property is not set, it's just like inherited from the parent. If it's set, it overrides. This is very kind of generic example, but what we actually have in OpenSync graph is this kind of implementation. It's called directed acyclic graph. So what kind of difference do you see between this one and the tree we had before? So here we have very strict structured hierarchy, right? So what is different here? How DAG is different from like simple tree representation? Yeah?
Any node can have more than one power.
Yeah, yeah, that's true. So, well, once we have like strict structure here, in this case we can have actually shared branches between the nodes, or like if we say the other way around, a node can have 2 different parents, and we can have this correlation, like this kind of relation. Or I think it's here. So yeah, or you can have also a relation between the children of the original one. For example, those 3 are at the same level, and the child of those ones and the child of those ones are also like correlated. So this one is child of this one and this one. So you can have this connectedness between the children on the same level, also several parents to the same child. But yeah, this is more complex. But there is one very important condition, one very strict condition, that we can't have, we can't go backwards. So if, for example, you can go have parent to child relation from bottom part of the tree to the top part. For example, like A cannot be child of E, so you can go this way. Or let's say 7 cannot be child of 9, so you can't have this kind of relation. So any idea why is it necessary condition to consider? Yeah?
Well, if 11 inherits from 7, 9 inherits from 11, and 7 inherits from 9, then you get it. That doesn't work. It's like it's a cycle.
Yeah.
At that point, who's the starting point? Where do I start?
Yeah, you can
falling apart pretty quickly.
You can specify the first level as a starting point, but there is another. Yeah, the logic is right. So the problem is that we will get infinite loop. So if you go from here, if you go to here to inherit stuff, and from here, if you go to here to inherit, and from here you go to this one to inherit stuff, you will have infinite loop, and you will, like, it will just crash. So it's very important to have this condition that you can have these links from top to bottom on the same level, but never the link from bottom to the top, because you might end with infinite loop. And yeah, any example where, for example, shared child can be useful? Why two branches, for why two parents might need to share the child node? Like, what kind of model can it be? Any example? Like, there are no right or wrong answers. Yeah.
If I have a parent node teacher and a parent node student, there might be a child that's both a teacher and a student at the same time. So you would need the functionality of both a teacher and a student at the same time.
Yes, but why can't it be? Okay, so why can't it be like then two different children of the same node? If you have like some human and you want to have like child, like student and teacher, you can have two children nodes, right? Or is that what you mean? Or
no, well, I mean, sure, you have a human and then you have a student and a teacher. But what if there's someone that's both a student and a teacher at the same time? So you need the functionality of both at the same time.
Okay, yeah. Then yeah, that can be the case. Yeah, and then you will need probably separate node that will be child of student and child of teacher, but should kind of maybe override the conflicting properties. Yeah, that can be the case. Or another case like here can be a wheel or tire. So imagine you have a car and you have a trailer that is connected to the car. So both of them, this wheel is actually technically part of both of them. So if you move the car, the wheel also moves, and if we move the trailer, the wheel moves. So it can be like part of the both at the same time. Yeah, this example is more when it's structurally needed to, like, actual physical structure requires to have this kind of links. But what you said is also makes sense, that you need to inherit similar things from two different nodes. Yeah, that also makes sense. Yeah, so it can be as complicated as this one in reality, but yeah, the only thing that you need to bear in mind that no links from bottom to top, otherwise you will be alright. So the tool will do the management for you, but like it can become really complicated. Like for example, yeah, to get back here, to start from the world, what can be the groups and meshes? Like, imagine the scene, what we can have here, like examples. Like we have the whole, let's say, landscape, we have some lighting in that landscape, we have camera looking at this landscape, and then, okay, let's say we have ground and trees are attached like to the ground, and maybe houses, and then we have like several meshes, like the body, the small branches, leaves, etc. And on this side we have walls, roof, a door, window. So, and when we, for example, change the lighting in the landscape, in the scene, it impacts all of those, because when we change the lighting conditions, it impacts appearance of like tree, appearance of the house, all the leaves, so it just passes down this direction. Okay, let's go on. So yeah, and the states are not necessarily passed down to the identical way. For example, we have the wheel mesh here, and we have some like group node that is up in the hierarchy, and this wheel is rendered 4 times. But it's not necessary that those ways down to the wheel are identical. So if you want to have one of the instances that is red, you can add a separate node in between to override this black and manage that in that way. And yeah, you change, like when you go from top to bottom, you simply change the state, you change the color at this point, and you will have red here, not the black. So you define the route from top to bottom, and you define the state. Yeah, or scene graph libraries like OpenSceneGraph, the example we have discussed today, and this is the one we will be working on tomorrow on the tomorrow's lab. But there are like a lot more, like OpenSG, there are like Java implementations, VRML that was later replaced by X3D. We had this last time, so that model format that was shown on the web that has support of its own scene graph. So there are like different ways, so it's not only OpenSceneGraph, it's just like the one we're dealing with within this course. And one thing you need to bear in mind as developers is that each of those are more or less suited to particular application. So if you select to use one of those, you might limit yourself to a single framework without possibility to generalize them. So all those ones are more or less limited to particular framework and implementation. So it should depend on the application you need scene graphs for. So here is general architecture of OpenSceneGraph. So we have some plugins that are for additional functionalities. We'll have a look at this. So we have core, and I will go into details through this one. And we have some node kits that solve very frequent problems in rendering. So it's not only about hierarchy, it also supports some capabilities of rendering and graphics related problems. So if we have a closer look to the core, I think threads are not given here. Yeah, open threads are just for management of different threads when executing those operations, but the most important ones are those ones. So the OpenSceneGraph itself within the core, it has like 2 primary capabilities. It's for definition and management of the scene graph hierarchy itself, and it has also support of different rendering techniques or optimization of rendering, like for example texture rendering module or simulation module. And then there is this utilization that primarily serves for traversing the trees, so to go through the whole tree to visit each of the node and convert the content of each node into OpenGL calls. And it also has some rendering optimization stuff. And OpenSceneGraph database is for plugin management. It uses plugins to load different object formats. For example, there is plugin for object loader, plugin for X3D loader, and like it supports many different, I think even images like PNG loader, etc. So this one is for loading different formats, and for each format we have plugin based implementation. And the node kits are just like additional kind of bonus that come in addition to these hierarchical implementation possibilities, and they serve to solve some frequently encountered problems in graphics, like particle system. For example, when we want to render the fire, let's say, and it's very complicated to do through ray tracing or some common techniques. So there are like the visualization of fire is split into tiny particles that are rendered separately, or simulations, animations, text rendering, terrain rendering, etc., special effects. So OpenScene Graph is not only about hierarchy and management of links between objects, but it also has support of rendering improvement. Yeah, what kind of nodes and instances do we have in OpenScene Graph 3? So node is the base class that includes everything we have talked about so far. It can be used for grouping when it contains several children and then imposes some common parameters like texture, color, rotation matrix, everything, imposes that to the children. And there can be like several methods like transform that is used for geometric transformations by 4x4 metric. We have seen that in geometric transforms lecture. Switch node that is used to switch directions and select the right node you want to continue through the path. So I will give a good example of that. So level of detail, this one is when, for example, the object goes farther. We don't need that much details anymore because we don't see that much details. Light source is just a leaf node that defines the lighting for the scene. Another example of node is a geode, that is a composite word and is geometric node, and it simply defines the geometry like meshes we had here. So something like those meshes. So it is a leaf node, it doesn't have any children, but it includes geometric information that is called drawable. So every object we render within a scene is called a drawable, whatever the pipeline draws. And geode can have this billboard functionality that simply orients the drawable, so a mesh, towards the camera to make it visible. Yeah, as a switch node example. So imagine you have a traffic light and you have like 3 different nodes, red, green and blue, and you have like this implemented in this node, like set color to red, set color to yellow, and sorry, I said blue, set color to yellow and set color to red. And using switch, you just select which node you want to continue. So you can have simultaneously red and green. If you want to have yellow light on a traffic light, you just, using switch, you go through this one. And the logic of switching is implemented within the switch node. And here is an example how to create it. So first, we create a switch node. Then we insert child nodes into switch nodes. Node A, node B, and node C, those are the indices. And then we turn just this node on. So we just like select node number 1, so it's node B. And yeah, as I said, there are drawables that are primarily geometry, so meshes, vertices, edges, lines, faces, texture coordinates. Also, there can be a text node that is for rendering text, or draw pixels that has implementation of GLDraw function and draws images, but I am not sure how is it better rather than just putting whatever is in the scene. Do you know like why draw pixels is better to use than just like simply let the model be rendered by given parameters? But yeah, if you have a look at this function, you'll probably get. State set is higher level. So it encapsulates all preset OpenGL states and attributes that you define from the very beginning. And texture is like texture rendering functionality. So the general principle is like this. So we have a group that is kind of root for everything else below it. We have a transform, which includes matrices that we need to use for in case of translation, rotation, or scaling. And then we have geometric nodes, so geodes that include the drawables, so meshes, actual models. Oh yeah, and by the way, this one is a very good tutorial on OpenScene Graph, so if you have a look at this, we can't cover everything in this lecture, but if you have a look at this tutorial, it shows like more code examples and more into details. Yeah, and the principle of implementing this one into a code is the following. So first you define the root node as a group. Then you define the geometry. So like some geometry for vertices, normals, colors also attached to that. Then you create a leaf node, so child node. Then you attach this geometry to the child node, and finally you attach child node to the parent and visualize everything. So define the parent, define the geometry, define the child, attach this geometry or drawable to the child node, and attach this child node that includes drawable to the parent node, and finally visualize that. So here is an example of that. So the root is defined, then child node is defined. Actually here the sequence is different, but it's actually the same. So you can first attach the child to the parent, or first put geometry into the child and attach with its geometry to the parent. And then we define geometry, attach that to the child node and visualize. So apparently both ways are okay. There are some built-in primitives that you don't really need to worry about. So if you don't have any shape defined and you need to test something very simple, you can use simple built-in primitives like this rectangular parallelepiped, sphere, cone, cylinder, and capsule. And here is the, so this one is called box, and here is a good example how to create a cylinder. So you first create a geometric node. So what was geometric node? How it's different from group node? Just want to make sure that you're more or less following. So we had group node, one type of nodes that groups can have many children and groups them together and passes similar parameters down to them. And what is the geometric node? It's the leaf node, so it can't have children. And what does it include? What's inside? So what does geometry imply?
It's defined in 3D.
Yeah, the drawable can be in 3D, but yeah, what's written there? Like very simple example. Yeah, so the mesh or the drawable, the object that is represented by vertices. Yeah, so you define this geometric node, and then you use shape drawable method, and you indicate that you want to define a cylinder, and you have 3 parameters: center coordinates, radius of the cylinder, and height of the cylinder. And once you define that, you can assign some color. In this case, we have red and blue set to 1, so it's a magenta. It's homogeneous color. And finally, what we do is that add drawable, we put this cylinder into this geode. So we define cylinder, define color for it, and add it to that node. So write it into the node. So writing into the node means like we have some group, we have this child node, and we put this vertex, color, face, everything information into here. Yeah, so some kind of brief summary about the OpenSync graph. It's pretty heavyweight system, as I already mentioned. So if you want something very simple, and if the links between the objects are not very complicated, you can do it yourself. But if you're dealing with a complex scene, like for example, as I mentioned, crowd, you'd better have some scene graph, open scene graph, or whatever the tool, because it will help you manage all those complex relations, especially like, for example, lighting that is very obvious, that impacts everything. It can be put at the top of the hierarchy, and then when you change the lighting in the environment, it passes down to whole scene. It uses plugins to load different models like OBJ files, like 3ds, X3D. So today I mentioned both OBJ and X3D. What is key difference in this sense here, in this context? What is the key difference between them?
OBJ is text, 3ds is binary, or?
No.
It was something with human readable?
X3D is also pretty human readable. If you remember, we saw here some scripts. No, not that kind of properties, but something fundamentals in context of scene graphs. Yeah?
3ds includes support from
it's not here. It's X3D actually. Yeah. Yeah, X3D has its own scene graph implementation embedded, while OBJ is simply mesh level. So OBJ just gives us information about the drawable, what are the vertices, what are the faces, color, texture, but OBJ cannot have any scene graph and hierarchy embedded inside. And another thing that is good with X3D is that OpenScene graph is a little bit chaotic to me because of lack of proper documentation and like clear specifications. While X3D is more or less standardized, it has ISO standard, and it is more or less standardized, stable, documented, so you can feel more comfortable reading the documentation of that one. But yeah, still it depends on your application. You need to bear in mind that when selecting either of the scene graph tools, you will kind of limit yourself to a particular framework, and sometimes it's directly provided and implemented in game engines or whatever framework you are working with. Yeah, this OSG native format for OpenScene graph is used to import or export plugins or hierarchies you created, or anything that you can like that. For example, tree you can define in OpenScene graph, and you can reuse it in the future, and you can use it, for example, in Blender or any external framework that supports that. And important thing about OpenScene graph is that it has lighting and camera included. Yeah, here is a good example. Well, yeah, as I said, it's an open project. So it started by 2 guys, I think, but then since 1999 it's an open source and it's an open project. Lots of people contributing on a regular basis, and there is always like new functionalities, new plugins added to that, so its capabilities increases. It's up to you how you will use them and how efficiently you will deal with that. And it's used in practice in lots of different projects. So if you go to that website I showed you today, you will see lots of examples. So this is just one of the examples. This is art, augmented reality toolkit for reality work. So and it uses open scene graph for scene graph implementation. And there are like many other projects that have used open scene graph in their framework. So if you need to write your own one, what you will need? Write the module loader, because in open scene graph you have plugins that, for example, plug into load OBJ file, but when you're starting from scratch you need to write your own module loader. You need to define the tree hierarchy, define all the nodes, all the dependencies and links between the nodes. You need to deal with deletion and addition of the nodes if you want to add additional nodes somewhere in your tree, or if you want to remove part of it. And you will need traversing algorithm, so the recursive algorithm that will go through that tree and visit all the nodes and execute what's inside. So in OpenStreamGraph it's already implemented for you in Traverse in the core. So it's called, let me see, utilization, yeah, OSG utilization. So you have traversers implemented there. So it's actually core OSG. But if you're writing your own one, you need something to tell the system, okay, go through the tree and pick up each of the nodes and check what's inside. And you might need to optimize your code and clean up the tree at the end when you're done with that. But yeah, it can be good to try a bit some simple scene graph if you really think that you will use it at some point in your career. So for assignment 2, it's not a requirement. You can use that, you can not. So it depends on the approach you select. But like, if you think that this was just a general overview to give more or less the idea, but if you think that you will be using this and this is useful in practice, it's better to start trying building your own one, because you will learn a lot and you will understand more how it works. So yeah, it's up to you and your interests. Yeah, that's more or less it about scene graphs and open scene graph. I left just like last 10 minutes because if you want to see your assignment 1 marks, I don't want to kind of announce that publicly. So I have all your marks here. Please come group by group and see the mark for your group. And that's all. Yeah, but before that, any questions? Now I have the feel that you didn't really follow all of it, but okay, then another question from me. What did you get from this lecture? So what do you remember and what was new that you learned here now? Yeah?
If I ever intend to have a lot of models, I should have a look at a scene graph at some point.
Yeah, and why is it good when you have lots of different models?
Because then instead of having to manipulate each vertex individually, I can use the open scene graph to like make that somewhat automated. So
Yeah.
I don't have to do it all manually.
Yeah, that's right. So anything else that will kind of remain in your memory after this lecture?
A little bit
about switch nodes. Like I noticed down a couple things I'll have to look up myself tonight.
Sorry, switch nodes and what's that?
Switch nodes and the scene graph libraries. A bit more about topology and stuff like that. I'll look up myself tonight.
Okay, topology and geometry.
Yeah.
We
So
don't need a C graph for assignment 2 necessarily, or
it's up to you actually. Depends what kind of architecture you select. So you can use it, but it's not mandatory. So you can do without that too. You can, because it's very simple, right? Especially if you select a Pac-Man. But if you want some curiosity task where you need lots of different modules with complex links with each other, then you might need that. So it depends on your curiosity task as well. So what was the tool I spoke most about, and we will have the lab about? So yeah, yeah, okay, yeah. I hope that you at least got general overview. I know it's pretty complex to kinda get all this like at once, but like hopefully I motivated you enough to look into and see whether this can be something useful for you. Alright, I will stop streaming and then you can come group by group, one by one, and have a look at your grades.